Hello, everybody. Good afternoon, evening, or morning. How's it going? Welcome back to Mr. Morrow's Algebra 1 and 2 class. Today we're going to be finishing up Chapter 1. We're going to be learning about Section 1.8, Simplifying Algebraic Expressions. As every single part of algebra, it's very important to really understand the vocabulary here and the processes and the methods. The more you understand Chapter 1 and the basics, the easier all the other chapters will be, I promise. So let's get right to it. We're going to have a lot of definitions today, guys, but it's going to be very useful. First of all, quantity. A quantity is a mathematical quantity is anything that can be measured or counted. Some quantities remain the same, and these are known as constants, and some vary, and these are known as variables. So anything that can be measured or counted, the amount of money in your wallet, the number of shoes in your closet, the number of pants you own, the number of shirts you own, the number of cars in a parking lot. All of those are quantities, anything you can count or anything that can be measured. Now, a variable. Think about the word variable. It relates to varies. A variable is a symbol, usually a letter, that represents the value of a quantity. Okay? Very popular variable is x. That's why we do not use x for multiplication anymore. For multiplication, we use a dot, or even better yet, parentheses. 2 times 3, it's better to write it 2 times 3 with the parentheses. So x is a very popular variable, so is n. But any letter that represents a quantity is a variable. A numerical expression. A numerical expression is a mathematical phrase or a sentence involving numbers and operation symbols, but no variables. Operation symbols would be plus, minus, multiplication. Actually, I just said not to use x, so multiplication and division. Those are what operation symbols are. So if you have a bunch of numbers involving operation symbols, no variables, it's a numerical expression. An algebraic expression is a numerical expression which includes one or more variables. So an example of a numerical expression would be 7 plus 6 minus 5. An example of an algebraic expression would be 2x plus 3, because there's a variable. All right, let us continue. When working with expressions and equations, it is important to know the following vocabulary. Now you know what a quantity is, and a variable, and an algebraic expression, and a numerical expression. Let's see what those expressions are made up of. What are the individual pieces called? Well, first of all, most important, it's a term. A term is an expression that is a number, a variable, or the product of a number and one or more variables. I'm just going to start giving examples of terms. 5, 2x, because that's a number and a variable to be multiplied. Z, VXY, 12, 17.6, negative 3W. All of those are terms. They're either numbers, just pure numbers, variables, just pure variables, or the product of numbers and variables, or the product of several variables together. Now, for each term, okay, there is going to be something called a coefficient, usually. And a coefficient is the numerical factor of a term being multiplied to a variable. So for example, if I just have the variable x, the number being multiplied in front of that x is a 1. So that is my coefficient. If I have 3x plus 2y minus 7, the 3 is a coefficient because it's being multiplied to x. The 2 is a coefficient because it's being multiplied to y. The 7 is not a coefficient. That's called a constant, and we'll get to that in a second. Actually, the next one. So a coefficient is the number being multiplied to a variable term. Okay? The number being multiplied to a variable term. It's the number in front of the variable. A constant term, think about the word constant. A constant term is just a term with no variables. It's just numbers. So if I gave you 5x plus 2y minus 12, the negative 12 would be the constant because it has no variables attached to it. And last but not least, you got to know how to recognize and work with like terms. Okay? Like terms. Terms that have the same variable raised to the same power. All terms can be multiplied, but only like terms can be added or subtracted. Think about going to the store. If you have 5 apples, and then your brother gets 5 more bananas, do you have 10 apples? The answer is no. Do you have 10 bananas? The answer is no. You have 5 apples and 5 bananas. Why can't you add them together? Because they're not the same thing. They're not the same object. They're not like terms. They're not like terms. Okay? So like terms are terms that have the same variable raised to the same power. Okay? Terms that have the same variable raised to the same power. So for example, 3x plus 5x. You can add those. The variable is x, the power is 1. 3x's plus 5x's, that's 8x's. That's fine. You cannot add these. 3x squared plus 5x. This has an x squared. This has an x. They're not like terms. They have the same variable, but they do not have the same exponent. So like terms are terms that have the same variable, same variable and same exponent. They're raised to the same power. All right, let's check it out. Identify A, the terms, the coefficients, the constants, and like terms, if any. Okay, so let's do this. The terms. The terms here are negative 4ax, 7w, and negative 6. Okay? Terms are separated by plus or minus signs. Terms are separated by plus or minus signs. So my terms are negative 4ax, a positive 7w, and a negative 6. Terms are separated by plus and minus signs. Coefficients. Well, the coefficients here are going to be negative 4, as this guy belongs to the ax, and also 7. C, constants. The only constant here is negative 6, and there are no like terms because I have an ax and a w. Those are not the same variables, and they're definitely not raised to the same power, so there are no like terms. Okay, number 2. Let's look at the terms here. A, the terms. The terms are 3x squared, 5x squared, 9y cubed z, 2yz, and a negative 4y cubed z. Those are the terms. My coefficients. My coefficients are 3, 5, 9, 2, and negative 4. The sign of the coefficient must appear as well. C, the constants. There are none this time. No constants. There are no numbers by themselves without variables. And the like terms, we're not going to combine them yet, but the like terms are 3x squared and 5x squared. I can add those because those are like terms. And I also have 9y cubed z and, not 4, but negative 4, and negative 4y cubed z. All right, let's continue. For number 3, before you do anything, always simplify if you can, okay? If it's possible, simplify. So I've got 8x minus 3y plus 6x plus 5. Now, let's go through the process. A, the terms. The terms are 8x, negative 3y, 6x, and 5. The coefficients are 8, negative 3, and 6. The constant is 5. My like terms in this example are 8x and 6x. There are no other like terms. And last but not least, the terms. The terms here are 2x squared, negative 8y cubed, negative 6x squared. Remember, terms are separated by plus or minus signs. B, the coefficients. It's got a coefficient of 2, negative 8, and negative 6. C, the constant. There's none in this case. There are no numbers by themselves. And D, the like terms. We've got 2x squared and negative 6x squared. Okay? Now, we've got a lot of usage of exponents here. So I thought it would be prudent to go over some basic exponents with you right now. When we're talking about exponents or powers, please understand what we mean here. Okay? When you have something like shown here, 2 to the third power, okay, the 2, excuse me, the 2 is the base, all right? That is the base. That is the number that is going to have repeated multiplication. The little number at the top of the base, that is called the exponent, or sometimes they call it the power. Okay? And the exponent or power tells the reader how many times to multiply the base by itself. So when I have 2 to the third power here, that means it's 2 times 2 times 2, which is 8. It's 2 to the third power. They want you to multiply 2 times itself 3 times. Okay? They want you to multiply 2 times itself 3 times. Now, reading exponents. This is a very, very good skill. Always read exponents as follows. You're going to read the base to the blank power. For example, 3 with an exponent of 4 is read 3 to the 4th power, 3 to the 5th power, 3 to the 6th power, 3 to the 7th power. Very simple. There's 2 exceptions, though, where you don't say the blank power. When the power of 2, okay, the power of 2 is read as squared. The power of 3 is read as cubed. So here where I have 4 to the 2nd power, I could read that as 4 squared. Here where I have 8 to the 3rd power, I could read that as 8 cubed. Okay, those are the 2 exceptions. Everything else is just to that power. If I just have 5, just a little reminder for you guys, please know that there's always an exponent of 1. So 5 to the 1st power is how you would describe that. Okay, whenever you have a number like 5, it's being divided by a 1, multiplied by a 1, and raised to the 1st power. All right, let's continue. Now, evaluating. To evaluate an algebraic expression, you're simply going to substitute a given number for each variable in the expression. Then simplify using the order of operations. What is the value of the expression for the given values of the variables? Okay. You have 7 times parentheses a plus 4 plus 3b minus 8, where a is negative 4 and b is 5. Go ahead and literally plug in the value for A, plug in the value for B, and then follow the order of operations, which, if you guys remember, is Pemdas. Please excuse my dear Aunt Sally. Parentheses first, exponents second, multiplication and division in order from left to right, and addition and subtraction in order from left to right. Okay? So let's go ahead and do it. I've got 7 times A, which is negative 4, plus 4, plus 3 times B, which is 5, minus 8. Well, this is going to be parentheses first, so we do the inside here. That's 7 times 0 plus 3 times 5 minus 8. There are no exponents, so now I'm going to multiply and divide in order from left to right. 7 times 0 is 0 plus 15 minus 8. Now I add and subtract in order from left to right. 0 plus 15 is 15. 15 minus 8 equals 7. All right, let's continue. X over 2 plus y squared for x equals 1 and y equals 1/2. Literally plug in the values that were given to you and solve. So x is 1, so I've got 1/2 plus y. Whenever they give you a value for y, encapsulate it inside of a parenthesis, because the y is 1/2, but the value of y is being squared. So to avoid any confusion, always encapsulate what they give you in a parenthesis when you have a power attached to that. Okay? So that's going to be 1/2 squared. Well, I have 1/2 plus, remember 1/2 squared, that's 1/2 times 1/2, which is 1/4. Numerator times numerator, denominator times denominator. So 1/2 plus 1/4. Common denominator is 4, so this goes to, you're going to multiply 2 over 2 to top and bottom. So this goes to a 4, this goes to a 2. So my answer is 3/4. Easy peasy. Okay. 2 times parentheses x squared minus y squared, close parentheses, divided by 3, where x is 6 and y is negative 3. Literally, plug in the values that were given to you into each equation, into each variable, sorry. So 2 times, remember, it has an exponent, so I'm going to encapsulate it in a parentheses, 6 squared, minus, remember, it has an exponent, so I'm going to encapsulate it in a parentheses. Now, order of operations. We first got to do what's inside of the parentheses first, right in here, okay? But inside of the parentheses, I have exponents. So this is going to be 2 times 36. Please drop down that negative first, then calculate this. Do not multiply those negatives before the power. Exponents come before multiplication and division. So that's 36 minus 9. Okay, all of this is divided by 3. Sorry about that. So then this is 2 times 27 divided by 3. Let's make our life easy. 3 goes into 3 one time, 3 goes into 27 9 times. So my answer is 18. Hopefully that made a lot of sense. Give me 1 second. Okay, we're back. Sorry about that. All right, so let's continue. Now, let's look at some more properties here, guys. Properties for simplifying algebraic expressions. Okay, some of these are really easy, very, very understandable. Some of them I'm going to have to explain a little bit, so let's just go through it. First of all, please realize that we're working with real numbers. Let A, B, and C represent real numbers. Definition of subtraction. Well, remember when we were talking about integers? When you have A minus B, it's really reading A plus a negative B. Okay? Remember that there is no real subtraction. It's always addition. We're just either adding positive numbers together or negative numbers together or positive and negative numbers together. Definition of division. Well, A divided by B equals A over B, or A times 1 over B. Well, think about it. If I have A over B, doesn't that equal A over 1 times 1 over B? Because A times 1 equals A, and 1 times B equals B. Remember that when you're dividing, okay, the denominator cannot be 0. If the denominator is 0, then it's called undefined. Then the distributive property for subtraction. I'm also going to tell you the distributive property of addition as well. I don't know why they didn't include it in this sheet that I got. But basically what the distributive property says is you're going to distribute the outside value to everything inside of the parentheses. So A times B is AB minus A times C, which is AC. So when you distribute, you're going to multiply the outside variable or number sometimes to everything on the inside of the parentheses. As far as distributive property for addition, it's the same thing. A times B plus C will equal A times B, AB, plus A times C, which is AC. Multiplication by 0 is known as the zero product property. Okay, multiplication by 0, basically anything times 0 is 0. Done. Multiplication property of -1. Anything times -1 will change the sign. Okay? So if I have 5 times -1, it's going to be -5. If I have -5 times -1, it's going to be 5. So whenever I multiply a -1 to anything, I'm just changing the sign of that number or variable. Okay, opposite of a sum. Well, we're talking opposite of a sum is basically when you're distributing a negative. Whenever you have something like this, okay, a lot of times people freak out. Please remember that this is just simply a -1 being multiplied to everything. You're going to distribute a -1. So -1 times A will equal -A. -1 times B will equal -B. And there it is. Okay? The opposite of a difference. It's the same thing. It's basically the distributive property of -1. If I have negative times A minus B, well, I'm going to have a -1 times A, which equals -A, and a -1 times -B, which equals a positive B. Okay? So I hope that makes sense. All right. Opposite of a product, basically a negative times any product will change the sign of that product. And opposite of an opposite, we already learned that with integers, a negative times a negative equals a positive. Okay, those properties are important, so I hope you understood them. If not, please look back at them or ask me any questions you want in class. All right, let's simplify each algebraic expression. When they tell you to simplify, they want you to combine like terms and get it as simplified as possible, my friends. So I have a really, I think, a good way of doing this. I like to show myself what the like terms are. So I know that 7x squared and -4x squared are like terms, so I'm going to use circles for those. I know that 3y squared and 2y squared are like terms, so I'm going to use triangles. Now, visually, I can see which terms are like terms, which terms can be added together. So I have 7x squared minus 4x squared. That's a 3x squared. Goodbye, goodbye. Done. Don't have to worry now. Plus 3y squared plus 2y squared is 5y squared. Goodbye, goodbye. Nice and easy. Okay, number 2. Check it out. You got this negative here. Remember that that negative has to be distributed. So we're going to distribute. We're going to use the distributive property always first before we simplify an expression. In fact, when we're solving equations, you have to also go ahead and perform the distributive property first before you solve the equation. So here we're going to distribute before we simplify the expression. So I've got this negative 1. I'm going to distribute it to everything. So I've got negative 3k minus m plus 2k minus 8m. Now, like I always do, negative 3k and positive 2k are like terms, and negative m and negative 8m are like terms. So negative 3k plus 2k, think about it. Use your integer operation rules. When the signs are opposite, subtract as normal and keep the sign of the largest absolute value. I've got 3 negative k's and 2 positive k's. So 3 minus 2 is 1, but I've got more negatives than positives, so I've got a negative k. I got negative m and a negative 8m. Well, when the signs are the same, you add and keep the sign, so that's negative 9m. And you are done. Okay, so another one. Negative 4j squared minus 7k plus 5j plus j squared. Well, I know that negative 4j squared and positive j squared are like terms. The negative 7k and the 5j are not. So negative 4j squared plus 1j squared, when the signs are opposite, you subtract as normal. Keep the sign of the largest absolute value. 4 minus 1 is 3, but there's more negatives than positives. So negative 3j squared minus 7k plus 5j. And last but definitely not least, let's go ahead and simplify this. Please remember, you must distribute before you simplify expressions. So this negative 1 gets distributed. Negative 1 times 8x is negative 8x. Negative 1 times 3y is negative 3y. Plus 10 times 2x is 20x. And 10 times negative 5y is negative 50y. Now, let's go ahead and combine like terms. I've got negative 8x and I've got positive 20x. I've got a negative 3y and I've got a negative 50y. All right, let's combine like terms. Negative 8x plus 20x, that's 12x. Negative 3y minus 50y, signs are the same. You add and keep the sign. That's negative 53y. And that's it. You are done. All right, I hope you enjoyed this lesson. I hope you learned a lot. Thank you very much. Have a great day, and I will see you in class. Bye-bye.